Video we're going to explore the properties of logarithms, and there are three main properties that we're going to be looking at here, but we refer to these as the product property, the quotient property, and the power property. You're going to notice underneath each one here I listed two ways. Essentially the first way is general base A, so some base A, but in the second way I listed as the natural log properties. Okay, so just know that it holds true for anything where the bases are the same across the board here, but the bases do have to be the same using these properties. But essentially we start with this first one here. Now recall that a logarithm, what is a logarithm? It is an exponent, okay? So when you look at something like this, we say log base A, of uv, we're saying A to what power turned into like u times b here, but we're saying that this represents some exponent, okay? So when you are, multiplying things that have the same base here, essentially, what we know is this, at least in an algebraic sense, we say x to the a times x to the b. What do you typically do when you multiply two things with the same bases? You add the exponents. So really what you're seeing here is we're saying the log of a product. Basically, if you were multiplying in here, then what we could do is we could split this up into a sum and just add the two exponents instead. So we say log of the first thing plus the log of the second thing, so long as we keep the same base. Same thing true with natural log. We say natural log of u times v is the same thing as natural log of the first thing plus natural log of the second thing, since we're just adding the exponents. That's what we're representing here. So likewise, when you divide two things with the same bases, in algebraic sense, we say x to the a over x to the b. We get x to the quantity a minus b. You subtract their exponents. And so the same thing's going to happen here. If we take the log base a of a quotient here, we can rewrite this as the log base a of the thing on the top, the numerator, minus the log base a of the thing on the bottom, which is our denominator. And one thing you want to write here is that it's important. What is important? We say order. Order is important when you do this because we say the numerator expression minus the denominator expression. Notice I said expression. This could be like a whole algebraic expression instead of just a u. So same thing here with natural log expressions. And then really quickly, my favorite property is the power property, which basically says, look, if you take the log base, something of an exponential expression, then that exponent, you are allowed to take it and put it out front instead of stashing it here on your, your thing you're taking the log of. So we say the power property says you can move your powers out front. And just remember, as we do these, all of these properties work both ways. So I could take a sum and put it back together into a single, product in here. I could take a difference and change it back into the log of a quotient, or I could take something like this and I could put it back up on the power, okay? So we're going to expand a couple of expressions here, talk about how you can go backwards and then call it good. But basically, let's take a look at this first expression here. Now I notice what am I expected to do here is expand this. So what we're going to do is we're going to take this log here, we're using our properties on the left, and we're going to rewrite it as an expanded expression where instead of taking the log of all of this, which is 5 times something to the power of 3 times something, we can write it as the log of a bunch of just individual stuff. Like you see up here, we say log of just u plus log of just b. That's kind of our main goal here. So we're going to look at this and we say, well, the first thing you look for, number one, are any products. Do you see any products here? Actually, let me scratch that out. We'll call that number two. We'll say this. Number one is, do I see any quotients? Quotients. I would want to split up quotients first. Okay, I don't see any quotients here on the inside of this, so I'm going to work with products next. But we say products next and then powers last when you are expanding. So what I mean by this is if I don't see a quotient, look for anything that's a product. And I do see products. I'm going to highlight those here. But we're going to rewrite this now as log, instead log base 4 of just the first thing in this product, which is of 5, plus log base 4 of x to the third power, plus log base 4 of y. And you'll notice that everywhere that there was a product symbol inside here, now that there's a sum here. Okay, so we use this first property of logs that say the log of a product is the sum of the logs of the individual things in that product. Okay, it's factors. So now there's one last thing we want to check for, powers, and you're always just going to be looking up here, but we say we can take this 3 and we can put it out front. So we get this expression here that's expanded. We say log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. And then you'll notice here that all of these on the inside of here, the thing we're taking the logs of, the things we're taking the logs of, they're just individual simple expressions. Okay, so this is our expanded expression. Okay, so let's take a look at this last example. You do want to see this one. The reasoning behind this is because you see a radical, and whenever we talk about radicals, like for instance square root, we are going to rewrite that as a to the 1/2, like if you had this here. And remember, that's just saying that we're taking it to the first power. This top number represents the power, and this number out here, the index, That's the index right there. Okay, so for a power in general, we say like x to the a over b power. That's the same thing as x to the a power bth root. So when we look at something like this here, I say the natural log of this giant quotient here. I've got a giant quotient. It's giant. And then we say, okay, first thing I look for are quotients. I notice I have one here, so I'm going to say this is like my u on top, and this is like my v on bottom. We're going to use a second property. It says the log of the quotient is the difference of the log of the individual parts. So we say this would be like ln of my u, the thing that was on top, which is the square root of 3x minus 5, minus the natural log now of the second thing, which is this thing in the denominator. So now what we're going to do is we're going to rewrite this kind of a special way. We say ln of this thing, 3x minus 5, to the 1 over 2 minus the ln of 7. And we need to do this because, first of all, we're saying it's all of this stuff in here to the first power, but the square root of that. So we say this is our 1 over 2. But that power needs to come out front. So we get 1/2 the natural log. Let me get that out of here. The natural log of 3x minus 5 minus the natural log of 7. Now the question is, do I keep going here? And the answer is no. But you say, well, there's a product right here. There's a product right here. But see, it is not glued into a product with this minus 5. So these are kind of distinct here. So this whole thing right here represents some number, like some u. There is no v in there with it, okay? So we'd say that this is the expanded expression. So when you put these things back together, we're going to refer to that as condensing expressions. But basically, you're going to go through, put powers back first, then products, then quotients. So, a good exercise is to go through these and put them back together.